Nuvasive for injection, aretavancin diphosphate, is a semi-synthetic, structurally unique lipoglycopeptide antibiotic that is active in vitro against gram-positive bacteria, including resistant strains. Nuvasive works through multiple modes of action. These modes include binding to a cell wall precursor that is required for cell wall elongation, and anchoring to the cell membrane to inhibit cell wall biosynthesis. Nuvasive also interacts with the cytoplasmic membrane and destroys the membrane permeability barrier of the bacterial cell. Nuvasive was derived from a naturally occurring antibiotic, chloraromamycin, which was discovered in a soil sample from Haiti. The chemical structure of Nuvasive is closely related to the first reported glycopeptide, vancomycin. However, Nuvasive has an additional sugar and a unique lipophilic side chain. This chlorobiphenyl methyl side chain or tail was added to chloraromamycin to form Nuvasive. Most gram-positive agents have only one mechanism of action against gram-positive bacteria. However, as a lipoglycopeptide, Nuvasive has multiple modes of action. Nuvasive inhibits cell wall growth and damages cell membranes in aerobic and anaerobic gram-positive bacteria, including strains that have become resistant to other currently available antibiotics. It exhibits concentration-dependent rapid bactericidal activity in vitro against a broad spectrum of gram-positive bacteria, including methicillin-resistant Staphylococcus aureus, MRSA, vancomycin-resistant Staphylococcus aureus, VRSA, and vancomycin-resistant Enterococci, VRE. Nuvasive is highly dimerized in solution. This means that it exists as pairs of molecules, which enhances its antibacterial activity. The lipophilic side chain and the additional sugar not only make the strong dimerization possible, but also allow Nuvasive to anchor into the membrane and bind to precursors that other glycopeptides cannot. Like all glycopeptides, Nuvasive inhibits cell wall biosynthesis by binding to the precursors that build the cell wall. However, the precursor in vancomycin-resistant bacteria, Acetiala delac, is different from that in vancomycin-susceptible bacteria, Acetiala diala. Unlike other glycopeptides, Nuvasive binds to precursors containing either Acetiala diala or Acetiala delac, stopping cell wall elongation and preventing cell wall formation in both vancomycin-susceptible and resistant bacteria. This binding makes Nuvasive active in vitro against both VRSA and VRE. Nuvasive can bind to the bacterial cytoplasmic membrane via its side chain. This both rapidly depolarizes the membrane and perturbs the membrane barrier function, preventing the cell wall from further synthesis and resulting in cell death. Nuvasive may inhibit both transglycosylase and transpeptidase enzymes to prevent cell wall biosynthesis. The inhibition of transglycosylase may be due to a direct effect on the enzyme. The additional sugar allows Nuvasive to partially inhibit RNA biosynthesis. These multiple modes of action contribute to the rapid bactericidal activity of Nuvasive. In summary, the unique chemical structure of Nuvasive contributes to its rapid in vitro bactericidal activity against gram-positive pathogens. Nuvasive inhibits cell wall biosynthesis, disrupts transmembrane potential, and destroys the cell membrane permeability barrier. Nuvasive is strongly dimerized, which enhances its antibacterial activity in both vancomycin-susceptible and resistant bacteria. Nuvasive may inhibit transpeptidase and may directly inhibit transglycosylase, further inhibiting cell wall formation. Nuvasive also partially inhibits RNA biosynthesis. Nuvasive has demonstrated rapid, potent, in vitro bactericidal activity against bacteria that cause serious gram-positive infections, including resistant strains such as MRSA, VRSA, and VRE.